continue graphing today, but we're actually gonna get more specific with our graphs, I guess you could say. You know how yesterday I like plotted a whole bunch of x-intercepts and then we kind of worked on like, how do I travel through them? Like, do I go through them or not through them? We kind of had to think about that a little bit. Today, we're going to learn about something called multiplicity. And that multiplicity tells you whether you go through the x-intercept or not. So it will actually inform you on exactly the path you should travel. There's no guessing involved, okay? That's what multiplicity means. All right, so polynomial multiplicity. The definition of this is the number of times a zero of a polynomial function occurs. So what I mean by that is, say, for example, I factored a polynomial for you and I told you it was to the power of 3. Remember, we had that yesterday a lot. That means we have x minus 2, x minus 2, x minus 2. We have 3 of those. Okay, this number right here, that's our multiplicity. Okay, so that will describe for us our behavior of the graph at that x-intercept. Okay. So the shape of the graph of a function close to a 0 depends on its multiplicity. We're going to get into the definitions of multiplicity and what each exponent tells us to do, okay? Here's just another example. For example, this function here, x minus 1 squared, x plus 2, has a multiplicity 2 at x equals 1. So I got that information from this here. So at the factor of x minus 1, that tells me I have an x-intercept actually at x equals 1, and the multiplicity is 2 because that's the exponent. So to figure out the multiplicity, you just look at the exponent, okay? So we're going to get into what each multiplicity actually means now. So if you have a multiplicity of 1, which means the exponent on the bracket or brackets is 1, which we have here, what that means is our graph will cross the x-axis at that intercept like a straight line. So we will cross. We won't just go to that x-intercept and come back down. We will truly cross it, okay? So, for example, let's draw out what I mean. I like creating a little table. You do not have to do this, but it's just how I organize things in my brain, okay? I know that I have roots or zeros or x-intercepts. Those all mean the same thing. I have an x-intercept at -1, at +1, and at +2. I got those values by just setting these 3 equal to 0 and solving. So I know I have an x-intercept at -1. I know I have an x-intercept at 1, and I know I have an x-intercept at 2. Okay, now on the other side of my table, I write the multiplicity, which is the exponent. So from this first bracket here, which is this guy here, the multiplicity is 1. The next one, this bracket here, which is this root here, again, the multiplicity is 1. And it's 1 for all of them. That means at each of those x-intercepts, we will be crossing like a straight line. We will go directly through, okay? So let's draw this now. I know that this graph is degree 3. We learned about that yesterday, right? Because to figure out the degree, you take all of your x values, which are just x, and that equals x cubed, right? So that's how I know I'm degree 3. Or the other way you can figure out is just tally these up. That also gives you 3. So that's how you know your degree. Okay, I have a degree 3 and my leading coefficient is positive. So that means my arrows will be in the opposite direction, but my end arrow will be pointing up and my beginning arrow will be pointing down. And now my y-intercept, we can't forget about that. Sometimes we forget about that. Your y-intercept is always your constant. Okay, well, my constant, like we learned yesterday, comes from multiplying all of the constants together from those factors I gave you. So +1, -1, -2. So your y-intercept is at y equals 2. So I'm also going to plot that. All right, let's start traveling up. I know when I hit my exponent of -1, my multiplicity there is 1, so I know I have to go straight through. And if I go straight through, I can see right away I'm led to that y-intercept. Okay, now at the y-intercept doesn't have a multiplicity. It doesn't tell us what to do, but we can just tell we have to start coming down because we've got to hit that next guy. Okay, the next guy, at that y-intercept of 1, it's a multiplicity of 1. So I know I must go through. I don't just bounce. I have to go through. And then my next x-intercept at 2 also has a multiplicity of 1, which means I go right through. So all of these x-intercepts had a multiplicity of 1, so we crossed. We never just touched it and bounced back up. So it just kind of helps us know what to do. Okay, that's what multiplicities do. So that's an example of multiplicity 1, when your exponent is 1. Okay, let's go to multiplicity 2 or any even exponent. So if you have a 2, a 4, a 6, an 8, it's all the same. The behavior is always the same. Okay? And when I think of multiplicity 2, like when I think of an exponent of 2, I think about a parabola, personally, because exponent 2 is a parabola, right? And when we do parabolas, we always bounce back. We don't cross through. A parabola is a hump, right? So it's the same thing here. So the behavior for a multiplicity of 2 is we will touch the x-axis at that x-intercept, but we do not cross. We don't cross through. We come back down or we go back up. We bounce. I kind of think of it as a bounce. We don't cross, okay? Bouncing is not the proper math term. I just invented that. The proper math term is we say it's tangent, okay? It just touches, but it doesn't cross. That's the definition of tangent. Okay, so let's see here. Here I have y equals x plus 2, and I see that this factor has a multiplicity of 2, and then I have another factor of x, and that has a multiplicity of 4. So those are the same behavior because multiplicity of 2 works for any even exponent. It's the same behavior. I'm going to make a chart. Again, you don't have to do this, but it's just how I organize my work. So on the left, I put what my x-intercepts are, or my roots, or my zeros, same thing. And on the right, I write what the multiplicity is at that root. Okay, so my roots here are my x-intercepts. My first one is a -2. You set it equal to 0 and solve. And then my next x-intercept that comes from just that x factor, that means I have an x-intercept at 0. If it's just x, that's a 0. Okay, the multiplicity at that -2 factor, or -2 x-intercept, is 2, and the multiplicity at that guy is 4. So in both of those cases, we're not going to cross, we're going to bounce, all right? Also, to figure out your degree, you can just add these guys together, okay? So 2 plus 4, I have a degree 6. I can tell that my leading coefficient here, or my entire parabola is, or not parabola, sorry, my entire polynomial is positive. So degree 6 positive, I should be both pointing up, okay? And then my y-intercept, whoops. To figure out your y-intercept, you multiply your constants together. Now, I hope you remember what I said yesterday. The constant from my first guy is a 2. We would square that because there's 2 of them. Remember that, right? It's 2 times 2 actually. But then what constant does this guy give me? 0. Remember we talked about that. That little bugger actually means there's a 0. It's technically to the power of 4, but it doesn't matter. Whenever you see a 0, you know the answer is 0. So I have a y-intercept at 0. Okay, let's go draw these. So I have an x-intercept at -2. I have an x-intercept at 0. And I just kind of circle it in red. That's also my y-intercept. It's common. Okay. Now, this is where it gets a little bit weird. You might get mad at me, and that's okay. We know this is an even degree, 6, yes? And I know it's positive, so I know I'm going to be like this. Now, up to this point, we have talked about if it's degree 6, we should see 6 movements. Do we agree? Okay. Somewhere, somebody in the history of math decided that drawing 6 bumps is too much work. Okay? Just stay with me. You're going to be mad at me, but that's okay. Or imagine we had a degree of 14. Who wants to draw 14 bumps? I mean, really, that's annoying, right? So what we do instead is we just use the multiplicity. So what I mean by that is when we come down, okay, I know I have to hit that -2, but because the multiplicity is 2, I know I don't cross, I bounce back up. We all good so far? Now, I see that I for sure have to cross through that x-intercept versus y-intercept. So I'm going to come back down. That is also an x-intercept. That also has a multiplicity. The multiplicity at that guy is 4. It behaves the same way as a 2. So we actually bounce back up. And my graph is done. But I don't have 6 bumps. I only have 4, but that's okay because somewhere somebody along the line decided that's okay. As long as we follow the multiplicity, this is actually the correct graph. Now, if I were to actually graph this on a graphing calculator, what it would look like is this guy would come down, it would bounce back up, and because this multiplicity here is 4, what they do is they say, well, we would just linger here a little bit. Remember how I talked about flattening out? Because 4 is a bit bigger than 2, and at 2, we just straight up bounce. At 4, because 4 is a bit higher, we flatten. You would see it flatten a little bit and then go back up. And that's how they make up for not having 6 bumps. Okay, so instead of having 6 bumps, they just say we're going to have 4 bumps, but at this multiplicity of 4, we will level out a little bit, and that makes up for not having those extra bumps. I know that's weird, okay? But I would rather draw 4 bumps than 6 bumps, or 13 bumps, or 18 bumps. So that's what multiplicity is today, is actually doing less bumps and more specific movements. Okay, let's try another one. Now we're in multiplicity 3. Okay, so we've done multiplicity 1, we've done 2, or all even numbers, and now we're at 3, or all odd numbers. Okay, so 3 is a kind of a combination of both of them, of both multiplicity 1 and 2. We cross at that x-intercept and also go tangent 2. So what that means is, and we've talked about degree 3 before. So degree 3 means we would say that's our x-intercept. We would cross it, but as we approach it, we flatten. So that's kind of our tangent part, and then go back up. So it's kind of a combination of the two. We cross, but also stay tangent there for a while. Okay? So that would be a degree 3. If it was a degree 5 or 7 or 9, I am not going to do 5 bumps or 7 bumps or 9 bumps. What we do is we treat it the same, but if it's a degree 5, we would flatten out for longer. That makes up for not having the extra bumps. If it were a degree 7, I would flatten out for way longer. And that makes up for not having the 7 bumps. So somebody along the line just decided, instead of having all those bumps, let's just flatten out. Literally do the opposite. Okay? So that's what that would look like, all right? So let's test it. Here we go. So I make my little chart. I organize my life. I see that I have an x-intercept at -2 and an x-intercept at +3. Multiplicity. At that exponent of -2, I have a multiplicity 3, which means I just kind of flatten out a smidge. And then at the root of 3, I have a multiplicity of 7, which means I'm going to flatten out a lot. Okay? My degree is 10, but we are not going to have 10 bumps anymore. Okay, the flattening out makes up for not having those 10 bumps. Okay. Also, it's negative though. Watch that, right? Your leading coefficient is negative. So we will be pointing down, but it's even. So it's an even degree. So we still have to find the degree to figure out if it's even or odd. So it's an even degree with a negative coefficient. So my arrows will be down at the end of the day. So it's a 3 to 4 behavior. Okay. Y-intercept. Now, this y-intercept is super fun. We're going to calculate it. And you're going to see right away that we're not actually going to draw this y-intercept because it's insane. So the y-intercept comes from your constants. But remember, once you, I'd like talking to the mic. I'm walking over to the board. That's why my voice is getting further away. Okay, remember, when you find your constant, you multiply the 2 and the -3 together to those respective powers. But also at the end of the day, this negative would get distributed in, right? So it's kind of like I have a negative first. That constant of 2 is to the power of 3. There's 3 of those guys. And then I also have a -3 constant, and there's actually 7 of those guys. So if you want to work that out, that's -8. 2 cubed is 8, right? -3 to the power of 7 is -2,187. You multiply those all together and you get 17,496. We will not be graphing that y-intercept clearly. So whenever you have a y-intercept that cruel, all you got to do is draw me a point up here or wherever and just label that as 17,496. Imagine we just skyrocketed really quick and got there super quick. All right, let's do this now. I have an x-intercept at -2. I have another one at 3. I've got my y-intercept plotted way up there. And I know my arrows, because it's even and negative, are down. Okay, so as I approach this first one, pay attention to its multiplicity. Its multiplicity is 3. So we will just slightly flatten. See how I slightly flattened? Because it's just 3. Then you would go up, you would reach that y-intercept, then you start your travel back down. Now, when you travel back down, this is a multiplicity of 7. That's pretty high. We should level out for quite a bit. So your kind of tangent here is going to really, that's not even enough in my opinion. More like that. No, that's not even enough in my opinion. More like that. There we go. Okay. So just kind of put emphasis on that part that you flatten. Okay. So this, because this multiplicity is 3, that's 7. This one should certainly be longer than that one. Okay. And that's how we make up for not drawing 10 bumps, because we would have to draw 10 movements otherwise, right? This is a whole lot easier. Okay. Now let's move on to something else. I give you a graph. I want us to determine the smallest degree possible. So like, what is the degree of this guy? And I want the smallest answer possible. because we know now that if we like flatten out, then we're not drawing all of our bumps. Maybe this is a degree 9. Like, we don't know. We know it's odd because of the arrows. It could be 9, it could be 11, it could be 13, because we're not drawing all the bumps anymore, right? So that's why I say determine the smallest one. We just go with the smallest one. I want you to figure out, what are my zeros or my roots, my x-intercepts? What's the multiplicity at that x-intercept? I want you to tell me, would the leading coefficient be positive or negative? And this is new today. I want you to tell me the intervals where the function is positive and negative. I'll explain that when we get there. Okay, now it also says for question A, so that's this graph here, I want you to determine a possible equation. So just give me any possible equation you think could work for this guy. But then for B, we're going to determine the exact equation, and we'll get to that on the other side. I'll explain the difference when we get to the other guy. Okay, so I'm going to create my chart again. I like my little chart. I feel like eventually you might like it too. Because when I make my little chart, I just start with the first x-intercept I see, and it is clear that I have an x-intercept at -2. So I write that down. And then I look at the behavior of the graph at that x-intercept. Did I cross through it? No, I completely bounced. When you completely bounce, that is a multiplicity of 2. It could be a 4, it could be a 6, it could be an 8. Right? But we are choosing the smallest possible. That's why I wrote the smallest possible. Okay, my next x-intercept is here at 4. So I write that down. And I ask, what is the behavior at 4? I didn't bounce. I crossed right through. And you can tell I didn't flatten out even a little bit. That is straight through. So if it's straight through, multiplicity is 1. Okay. So my degree then is 3. Now, my leading coefficient, would it be positive or negative? Negative, because your end arrow is pointing down. So that's how we know we have a negative leading coefficient. Okay, so if I have enough information now to create a possible equation, okay? My possible equation is y equals. You always start with y equals. All I know about my leading coefficient is that it's negative. It could be -2, it could be -5, it could be -10, but this is just possible. We're not getting super exact here. I just know it's negative. Okay. Then I start getting into my roots. I know that I have an x-intercept at -2. So that meant at some point, I had a factor in there of x plus 2, and I know the multiplicity on that guy is 2. I'm pulling this from my table. Then I know that I also had a root at 4, which means at one point I had a factor of x minus 4, and the multiplicity of that is 1. So I just leave it, and I'm done. I don't even put a y-intercept. Or not. This is like the lazy. Okay, so when I ask you for a possible equation, you get to be lazy. Don't even find the coefficient. Don't even find the y-intercept. Just call it a day. Now, positive and negative intervals. This is something new. If I ask you for the positive interval of this graph, what I mean is, where is the graph above the x-axis? So positive, as always, means above. Okay, so this is where the function is positive. And then where is the function negative? I want a new color for highlighter. Let's go yellow. Okay, this is where the function is negative, below. So that's all you do. You state for me the domain, like what x values represent that purple curve and what x values represent that yellow curve, okay? So I'll do it over here. So I, again, create a table. That's just how I work. I'm going to do the positive interval domain over here, and I'll do the negative interval domain on the right. You could just list it for me. I like tables. Okay. So the positive interval is the purple. Okay. Oops. Oops. There we go. So what's the domain of those x values? Well, if you look right here, this is kind of where our purple line or curve begins, and I get less than that. So x is less than 4. Okay, so that's it. X is less than 4. Now you might be wondering, why didn't you say less than or equal to 4? Because at this point here, it's on the x-axis, right? So it's neither positive or negative. It's neither above nor below. It's on. So that's not positive. Or it's not negative. It's on. Okay, like your y value is 0 there. It's neither positive or negative. So you leave it out. So that's why I say x is just less than 4. Because at 4, it's on the x-axis. It's neither above nor below. So that's that. That's your domain for the purple part. X is just less than 4. Because of this arrow here, it goes on forever to the left. Now for your negative interval, that's this guy here in yellow. It's that yellow piece. So that yellow piece also begins at 4, but is greater than. So you say x is greater than 4. Sorry, I blanked for a second. X is greater than 4. Not equal to. That's it. So my purple is less than 4. My yellow is greater than 4 in terms of x values. Okay. Now, we're not done. We talked about this guy, didn't we? What about that guy? We said how this x-intercept cannot be included in your domain. So it's the same for that guy. And that guy is part of the purple curve, right? So over here, you're also just going to add x can't be equal to -2 either. It's not equal to -2 because at -2, we are on. We are not above or below. So you can't include it in your domain of a positive interval. So you have to add that little extra piece in there, and that's forgotten quite often. So make sure you look at all of your x-intercepts. They should all be represented in that table. All right, let's move on to B. We're going to do this again. But now I said in the instructions for B, I want an exact equation. We're going to be very precise. And you'll see I gave you your y-intercept. That's why we're going to include that guy as well. And we're also going to include what the actual leading coefficient is, like the actual digit. Okay? So let's create our little table. I need to speed up here. I'm going to go quicker. So my table, roots, multiplicity at those roots. My first root I see is at -3. Do you see that it kind of levels out a little bit at that -3? Okay, so that means my multiplicity is 3. We're not going to go with 5 or 7 or 9. We go with the lowest. Then I have another root at 2, and that clearly goes straight through. There's your multiplicity. You also have a y-intercept at 2. That's important, but this tells us that we have a degree 4. And we should have a negative leading coefficient because my arrows are pointing down. Okay, so to be specific, an exact equation, you need to find what is the true leading coefficient. We know it's negative, but is it -2, -8, -10? We have to find it. And now we're going to do a throwback to Foundations 20 and Pre-Calc 20, because we did this in those classes. If I want to find what that leading coefficient is, we call that our A value. We have to find our A value, okay? So stay with me. What we're going to do is we're going to create our equation here. Y equals, I don't know what A is, but I'm going to find it, okay? Then what I know is that I have an x-intercept at -3, which means I had a factor of x plus 3 once upon a time, and my multiplicity there is 3. Then I know I had an x-intercept at 2, so I have a factor of x minus 2, and the multiplicity is 1. Okay, this is what I have to find now. If I want to find A, I have to plug something in for y and x so that A becomes my only unknown. We did this in Foundations 20 and Pre-Calc 20. All you do is pick a random point on the graph as your xy and plug that in. So I'm going to choose this random point. I know that on my graph, I have a point 0, 2. So I'm going to plug those values in, and then A will become my only unknown. I can solve for it. So y is 2, leave your A. X is 0, plug that in. So this bracket becomes not 9, sorry, I thought it was squared, 27. This bracket just becomes -2. So I have 2 equals -54A. I've just multiplied 27 and -2. You want to isolate A, divide off the -54. You reduce that always, and we just found that A is -1 on 27. Okay, so now when you create your equation, you are going to throw in that nice specific A we found, and then put those factors back in. And we do not have to actually put the y-intercept in, because it's not just 2 like that. Like, I know we cross at 2, but it's not just 2 like that, because remember, we have to factor everything out and multiply all these together and then distribute this, and the result is 2, but it's not actually a 2 in the equation. So that's the little bit of laziness I will allow here. You do not have to find the y-intercept. When I ask you to do an exact equation, this is the guy that you need to find, okay? Maybe a bonus question on your exam would be to find the y-intercept. It's a little bit tricky. Okay, last question of the day. We are going to do it all. We are bringing it all together now. I am giving you a polynomial. I have not factored it for you. We are going to factor it, which means we have to do synthetic division. We're going to figure out the multiplicities. We're going to figure out the degree, the leading coefficient, all of that fun stuff. And also on top of that, we're going to practice finding those positive and negative intervals again. This is where it all comes together. If you can handle this question, you're good. Okay? Let's roll. So here we go. This is the polynomial, and I have to factor that guy and find my x-intercepts. So this is where you guess. Remember, it's like we just have to test something, start dividing by something, but we see that that's a 4. And that brings me joy, because the only things that can divide into 4 are 1, 2, and 4. So I don't have a lot of options to choose from. What do we always typically start with? A 1. Okay? So let's start with x minus 1. So if I am testing x, the factor of x minus 1 in my synthetic division, that means I am putting a 1. Okay, and let's see how that works. So I have a 1. Synthetic division. Write your coefficients in order. I have a -1, a -2, a 3, a 4, and the constant is a -4. What are we hoping for? We're hoping for a remainder of 0. And remember, you could have tested this first. Remember the factor theorem we learned about where you just plug a 1 into the polynomial? If the result is 0, you know it passed the test and you can move forward with the synthetic division. I'm just going to risk it and just go right for the synthetic division, also because I know what the answer is, and this works. So I'm just trying to save time here, okay? We found one that works. Drop it, -1, multiply, -1, add, -3, -3, 0, 0, 4, 4, 0. Okay, I know I went fast there, but you know how to do synthetic division by now. I dropped all my values, multiplied them all by 1, added each stack, and we're happy because my remainder is 0. So I just found a factor. Good for us. 1 down, many to go. Okay, so now This right here gives you your new polynomial at 1 degree less. So negative x cubed, right? Minus 3x squared. I am skipping an x value. You see how it's 0x? So just don't write it, but you still have a plus 4 constant. So that's your new polynomial. So this is kind of like our new equation. That's our new guy. And we start over. What do you want to do? Want to go to 2 now? Or we could also go to x plus 1, right? Because you want to do the opposite symbol. Or do you want to move on to 2? Let's move on to 2. We're going to move on to 2. If we did x plus 1, it wouldn't work. Okay, so I'm just telling you. But you might have to test that and find out the hard way that it doesn't work, okay? All right, so now I am moving on. I am now going to test x plus 2, or actually I am testing negative 2. Again, do the factor theorem if you want and test it first before you get into the synthetic division. I don't care. Okay, synthetic division. I am testing by negative 2. Throw in your coefficients, and for the love of God, you have to put that 0 back in. Remember, we talked about missing terms. We have a missing term there. We need that 0 or else it'll be wrong. Okay, drop it down. Negative 1, 2, add. Negative 1, multiply. 2, add. That's 2. Multiply. That's negative 4. There's my 0. I'm happy. So we just found another factor that worked. Okay, I'm happy now. You want to know why I'm happy now? It's because when I rewrite this at 1 degree less, I have negative x squared minus x plus 2. That's my new equation now. And I see it's an x squared. I know how to factor those myself without synthetic division. Okay, so to factor this guy, we set it equal to 0. That's just a rule of thumb. I insist that you take that negative out, okay? Otherwise, you're going to probably factor it wrong. When you take that negative out, all the symbols change. And when I factor that, what two numbers multiply for negative 2 but also give you a positive 1? That would be x minus 1 and x plus 2. So we just found our other factors. And anyone want to take a guess at what this tells us? Our leading coefficient is negative. Because we have a negative just chilling out front. You can't just ignore that. But we also already knew that we had a negative leading coefficient. Okay? So now, I am going to write out my equation in the fully factored form so I can see my multiplicities, okay? So I'm just going to start with this first factor up here that I found was x minus 1. And guess what? We found another x minus 1. There's 2 of those guys when we ended up factoring it, right? Look at the 4 highlighted factors. There's 2 x minus 1s. That means I have a multiplicity now on that guy. Okay, the next guy is x plus 2. Oh my goodness! Look at that. I have 2 of those also. I also have that multiplicity on 2. Okay. And we're also not going to forget that that's my factored form, yes. And that will tell me my x-intercepts, yes. But remember, there's also a negative there. Yes, you have to remember that. That tells you the direction of your arrows, okay? And then for my y-intercept, I see students all the time trying to figure out the y-intercept using all these numbers like we've done before. Okay, I gave it to you. Don't be silly, okay? It's the constant in the polynomial. Don't do more work. Okay, let's go, let's go, let's go, let's go. All right. So I know that I have an x-intercept at 1. I know I have an x-intercept at negative 2. I know my degree is 4. It told me that in the original polynomial. So even, arrows in the same direction, but it's negative. So my arrows will be down. I also know I have a y-intercept at -4. And let's go. We work our way up. When I reach that, the multiplicity at that x-intercept is this right here. That's your multiplicity. And that tells you you bounce. You don't cross. So we bounce down. Okay, now I clearly see I have to start working my way up quickly to that guy there. At that x-intercept of 1, it is also a multiplicity of 2, which tells me I bounce. And look at that, we're done. That worked out so nicely. Okay, last thing we're going to do is we are going to create our table for our positive interval and our negative interval. Okay, above or below. And I'm going to even write that in. Positive interval is anything above the x-axis. Negative is anything below the x-axis. Okay, so what do we notice about my positive interval or anything above my x-axis? Someone talk to me, please. What do we notice about my graph above the x-axis? Does it go there? No, it does not. We don't even have a positive interval. Not applicable, nothing, no solution, leave it blank. I don't care. There is nothing about this graph above the x-axis. Okay, but our negative interval, we got stuff down low, right? How far left does this graph travel and how far right? I've got arrows on both ends. What does that mean? That's that freebie domain we talk about, right? X is an element of all real numbers, but what do we have to remember? It's strictly above or strictly below, Kai? It cannot be -2 and 1. Those are neither above nor below. That's on. That's not part of your negative interval. So yes, X is an element of reals, but X cannot be -2 and X cannot be 1. That's the completed domain. Okay? And that, everybody, is chapter 3. We're done. This question here was the culmination of all of it. So if that made sense to you, you're looking okay. Okay? Work period Monday to tackle whatever you need to tackle. I'm going to put out these 2 that goes with yesterday's lesson and today's lesson. And I'll write the required questions down here. And then this is your review for your exam. That's Tuesday. So come grab those. And ignore this. Okay. The required questions for this worksheet are. I thought I wrote them down somewhere. Just a second. Oh, I wrote it yesterday. Oh, I erased it. Does anyone have it written down still in their notes? Kai, what did I say? So page 148. Yeah. Number 4, AC, and 5. And then for the worksheet, I said even, didn't I? Even letters. Good? Okay. I'm going to end this meeting. Stop sharing. Here we go.